Good morning.
That was my daughter McKenna. She just woke up, so we don't have a lot of time. Let's move. So on the back side of the notes, we're going to do some operations with complex numbers, but we're actually going to use this trig form to help us with the process. So you'll see on the back side of the notes that there are two numbers being represented in trig form. So we have the z sub 1 and z sub 2 to represent those two different numbers. If you are ever asked to multiply two complex numbers together, and they are in trig form, you can use this formula where you will multiply the r values together, and then you are going to find the sum of your angles theta 1 plus theta 2 from each of those complex numbers, or that are now in trig form. And then same thing with quotient, you are going to divide the r values in front, but you are instead going to now subtract the angles. So let's look at a couple problems and talk about how this is done. If you're asked to find the product of two complex numbers and they are in trig form, we are going to multiply the r values. So this is your r1, this is your r2. So we'll do 3 times 11, which is what value, McKenna? What's 3 times 11?
33.
33, good job. And then we can take those angles. This is your theta 1. This is your theta 2.
3.
Okay. And we can add those angles together. So McKenna, what is 17 plus 63?
80.
80, good job. You're so smart. Now, that would be your final answer if asked to keep it in trig form. Sometimes, however, you will be asked to convert this to standard form. So if you're asked to convert to standard form, you would take the 33, and then we want to rewrite this as cosine 80 degrees plus I sine 80 degrees. And then what we can do is use our calculator. And we can, oh, my daughter was researching dolphins yesterday for fun. And then we can go to our mode, make sure we are in degree mode for this one, and we can do the 33 parentheses cosine 80. And
80.
Good job, McKenna. And then we get this value of approximately 5.73 plus, and then we can do the same thing. Think about distributing the 33.
Good morning.
Okay, McKenna, they get it sine 80, and then we're gonna get this 32 point, and then if we wanted to round this, we could go 5, and then I. And then that would be your answer in standard form. So it's good to know both of the forms because you'll be asked in different cases to write in trig or standard, and you need to know both. The second example in this set is now a division. There's a typo on this one, and I meant to fix it, but I mean, we're in outbreak time. I mean, who has time for that? If you could just add that 4 in there. But what we're going to do here is divide. This is your R1, this is your R2. So as I talked about before, we are going to divide the numbers in front, but you are going to, second time I did that, subtract the angles. So what we would get is this 3 pi minus 4 pi. McKenna, can you do that somewhere else, honey? Okay, can you just take that monkey and just, yeah. Well, they can still hear it, honey. This is sound. You just go take it in the other room.
It's done.
Okay, and then we get this negative pi. So if in trig form, this would be your final answer. But if they said standard form, actually this one's nice. We wouldn't have to use our calculator. You can rewrite this as 3 cosine the opposite of pi plus I sine the opposite of pi. And then from there, we can use our unit circle. So if you think about the opposite of pi, we're talking about over here. So this would be -1, 0. So we could fill in for the cosine a -1, for the sine a 0, And then note that when we distribute the 3, we would get a negative 3 as our final answer. Obviously, this part that's being multiplied with 0 would go away, and so then we would just get this real value of negative 3. So that is the answer for those 2 questions. The final part of this is asking you to do this 2 different ways. I'll do it for the product part, and then I'm going to have you guys try out the quotient and check with my answers. So for the first part of it, it says use trig form to multiply these 2 numbers together. So if we're doing z1 times z2, in order to use trig form, we have to take each of these right here and convert them to trig form. So going back to how the notes started, if you wanted this number z1 to be in trig form, we'd have to do a quick little sketch and think about how we're creating a triangle. And I know this is going to be kind of hard to do because we have a value just of 1, and then we would go down negative 1. So we're talking about, no, McKenna, stop touching things. No, not funny. So what we can do is we can find the r value, because if you think about it, it would be that 1 squared plus negative 1 squared. So what we're getting is an r value equal to the square root of 2. And then our angle here, we already know that when we do the tangent, we're going to get the tangent of theta to equal negative 1, because we're dividing the y by x. And then note that for this problem right here, we've seen this already in today's notes, that would be 7 pi over 4. So in trig form, this right here is root 2 kiss 7 pi over 4. Now, we have to do that same thing for this part right here. So for this part right here, think about how we would have to graph this.
How to grab there?
Okay, McKenna, your commentary is not helpful right now.
Not helpful right now.
Okay, I made a mistake.
Okay, I made a mistake.
Okay, this is not copy mommy right now.
This is not copy mommy right now.
I smell.
I smell.
You just said you smell. All right, go away.
Go away.
So if you're setting this,
I'm sorry.
okay, McKenna, come on, seriously. I'm gonna go away. I'm gonna lock myself in a room and not let you in. So if you're doing this problem right here and you are trying to get the trig form of this, you would have to do your r equals the square root of 3 squared.
Square to 2.
McKenna. Thank you, honey. R equals the square root of 3 plus 1, which equals the square root of 4, which would be 2 for your R value. And then for your angle, theta, kind of cool thing about this too is that you don't have to use tangent. I always use tangent because those are the givens, but you can also use like any ratio you want. You can technically say, hey, the sine of theta, and that would be your opposite over hypotenuse. So think about where in the first quadrant do we get a y value equal to a half, and note that that would be at that angle of pi over 6. So you don't necessarily have to use tangent, but we can get this then in that trig form by saying 2 kiss pi over 6. So going back to what we were originally asked to do, for this problem, you want to use trig form to find z1 times z2. So what we would do is we'd multiply the numbers in front together. So we would have the root 2 times the 2, or 2, bless you, root 2. And then because it's a product, we want to add our angles together. So we would want to take this 7 pi over 4. And we are going, oh my gosh, I just give up. And then we are going to add pi over 6. So to do that, we'll need a common denominator. We can make this a 12, which makes this a 21. And then we can make this a 12, which would make this a 2. So we end up getting 2 root 2 kiss, and then this would be 23 pi over 12. And then again, that would be your trig form answer. You can also convert this, and this will be great for us to check. So this is trig form. If you were to convert this to standard form, we would have to do the 2 root 2 times the cosine of 23 pi over 12. And then the 2 root 2 times the sine of 23 pi over 12. But then remember, we'd stick that I on at the end. So if you wanted to just check to see what that standard form would be, you would get the 2 root 2. And then cosine. Now I have to change my mode back. This can be very annoying having to change your mode, and you will have to do that a lot. So going back, cosine of 23. McKenna, can you please go somewhere else? Or at least say excuse me.
Excuse me.
My students don't want to hear you farting as I'm doing the notes. And then 2 root 2 sine 23 pi divided by 12. And then we're going to get this 0.732i. So note that these are the same answer for this, but in different forms. So trig, and then this is what we call standard. Now, for the second part of this, they want you to, again, find the product of these two, but instead of doing it using the formulas and converting to trig form, let's just actually multiply these numbers together in their complex form. So what we can do is we can take this 1 minus I, and we want to multiply that by the root 3 plus I. Now, we should get the same answer because this is just a different form that we use, a really cool formula, but it should give us the same thing that actually multiplying the complex numbers does. So if we multiply, we're going to get this root 3 plus I minus root 3I minus I squared. So what we're going to get here is this would become a positive 1. So remember, I squared equals negative 1, but since there's a negative in front, it becomes a plus 1. So what we can do is take our real numbers and put them together, and then we can take our imaginary parts and put them together. But let's factor out the I from those parts. So if I take out an I would have 1 minus root 3. And then I still have this real part of root 3 plus 1. Now note, if I do square root of 3 plus 1, I should get this decimal of 2.732, which I saw up here. And then over here, when I do the 1 minus the square root of 3, I'm going to get that same negative 0.732 with the I. So kind of cool showing you can still use the complex numbers that were given and you will get the same answer. But it is pretty neat that these give you that same answer. So what I would like for you guys to do is try out the final part of this, and I would like for you to now find the quotient in 2 different ways. So do the z1 divided by z2. I will create a third video to show the answer for this part. You can also check with the key as well.